Good morning, class. We are looking at college algebra prerequisite, and we're going to cover the first part. Starting with the basics, number sets. Natural numbers, also known as counting numbers or positive integers, contain the counting numbers 1, 2, 3, 4 to infinity. N, capital N, represents the set of natural numbers. The three dots are called ellipses and indicate that the numbers continue forever in the same pattern. Whole numbers, natural numbers and zero. So whole numbers, which normally we show with W, is the set containing 0, 1, 2, 3 to infinity. Integers, whole numbers and the opposite or negative of every natural number normally be represented with I. So 0, 1, 2, 3 to infinity on the negative side, negative 1, negative 2, negative 3, all the way to negative infinity. Rational numbers. Any real number that can be expressed in the form of A over B, in the form of a fraction, where A and B are integers and B can't be 0. In other words, every number we have studied here are considered rational numbers because all you have to do, put a 1 underneath and it becomes a rational number. Also decimals that terminate, for example, 0.2, because you can write it as 2 over 10, which becomes 1 over 5. Okay, or a repeating decimal, 0.3 bar, which is 1/3. Irrational numbers. Any real number that is not rational, like square root of 2, cube root of 4, pi, if you were to put those into a calculator, they will give you a decimal format that does not terminate. For example, pi is 3. Let me just write that for you. Pi is not equal to 3.14. Pi is 3.14159, and it continues indefinitely. So it's a non-repeating, non-terminating decimal. Real numbers, the union of the rational and irrational numbers are real numbers. So basically, all of these numbers are also considered real numbers. Absolute value. A given number's distance from 0 on a number line. Therefore, the absolute value of every real number is either positive or 0. Five units from 0, we go to the right, we go to the left. This distance is a 5, and therefore the absolute value of a number n is written as absolute value of n, and absolute value of 5 is 5, absolute value of negative 5 is also 5. So we can define an absolute value of any number as x, the absolute value of x is x if x is larger than or equal to 0, and it's minus x if x is less than 0. Please understand, this means the opposite of x. So if you want the absolute value of 5, because it's positive, just drop the absolute value sign. But for -5, you write negative of that, the opposite of that, which is 5. That's the meaning of absolute value in general. All right, review of exponents and polynomials. These are a bunch of them, and we should be pretty comfortable with those, everybody. A can't be 0, B can't be 0, a to the power of 0 is 1. That's called the zero exponent for any non-zero real number a. A to the power of 0 is 1. A to the power of m times a to the power of n is a to the power of m plus n. This is the product rule. A to the power of m to the power of n, you multiply the two exponents, is the power rule. This one, each one gets raised up. This is also called the quotient rule. A to the power of m over a to the power of n is a to the power of m minus n. Again, this is fairly common. Negative exponential rule. A to the power of minus n is 1 over a to the power of n. 1 over a to the power of minus n is a to the power of n. Meaning, if you have a negative exponent, just move it. If you have a negative exponent, if it's at the bottom, you move it, you bring it up. If it's at the top, you make it positive and you take it down. And that's the idea. All right. So with this being the case, 3 to the power of 0 must be 1. Negative 4 to the power of 0 must be 1. Now this one, I want you to be very careful. This part is 1, and the negative sign remains, so minus 1. So it's pretty straightforward, everybody. We want to find each product. We use the product rule. We add 4 and 7, and the answer is y to the power of 11. Now, just to do this in a couple of steps instead of just one step, let's put the numbers. We are multiplying everything, so we can put them in any order. Let's put the numbers next to each other. 6 times 9 times 2, and then z to the power of 5 times z cubed times z squared. Let's put them together in this fashion. So this one, 6 times 9, 54 times 2 is 108. And then z to the power of 5 plus 3 plus 2, which is 108 z to the power of 10. 108 z to the power of 10. All right, power rules for all positive integers, m and n, and all real numbers, a to the power of m to the power of n. You multiply these two, you get a to the power of mn. Ab to the power of m, you raise a to the power of m times b to the power of m. A over b to the power of m in the same fashion. A to the power of m over b to the power of m. Needless to say, as always, the denominator cannot be zero, so therefore b can't be zero. And therefore, if we follow this rule, this becomes 5 times to the power of 3 times 2, 5 to the power of 6. Three to the power of 4, x squared, in a parentheses, cubed. That means each one gets raised to the power of 3. So 3 to the power of 4 to the third power, and x squared to the third power. This is 3 to the power of 12. This is x to the power of 6. So 4 times 3, 2 times 3. 3 to the power of 12, x to the power of 6. Two to the power of 5 over b to the power of 4 quantity cubed. As always, the denominator can't be 0. That's why b is not equal. So even if we don't write that, that is a given, okay? So we basically follow these rules. For example, this one, and we're going to raise 2 to the power of 5 to the power of 3 over b to the power of 4 to the power of 3. Now the power rule, 2 to the power of 5 times 3, 15, over b to the power of 4 times 3, 12, and of course, b cannot be equal to 0. Like terms. Like terms are terms with the same variables raised to the same powers. Example, negative 13x cubed and 4x cubed. They are considered like terms. Negative x cubed, they are considered like terms because this part, that means the variable and the exponent must be identical. In this case, the coefficient is negative 13. In this case, the coefficient is 4. In this case, the coefficient is negative 1. So just as an example to write this, coefficient. So for this expression, the coefficient is the number that sits in front of the variable raised to a specific power. Polynomial. A polynomial is a term or a finite sum of terms with only non-negative integer exponents permitted on the variables. So what this means that the exponents are whole numbers. Otherwise, it is not considered a polynomial. And we can add like terms. By the way, if you happen to have a constant in number, the exponent is considered to be 0 for the variable. Now I want to add 2y to the power of 4 minus 3y squared plus y. You want to add this to the following parentheses, 4y to the power of 4 plus 7y squared plus 6y. We want to add them up, everybody. We can add like terms, which means we can add these two. We can add these two. And then these two. Why is that? When you look at these two, they have y to the power of 4. Therefore, they are like terms. So to add these two, 2 plus 4 times y to the power of 4. To add these two, negative 3 plus 7 y squared, and these two, 1 and 6. Again, do you have to write this step? If you're comfortable with just adding them just the way they are, this one and this one, they add up to 6y to the power of 4. This one and this one, they add up to 4y squared. And these two, they add up to 7y. So you don't need this step. Just wanted to emphasize that in case. Using FOIL to multiply two binomial special products. The concept of foiling, if you have two terms here, binomial refers to the fact that you're dealing with two terms. We have binomials, trinomials, three terms, and polynomials in general. So let me write those actually before we move on here. Monomials, this is one of them. Binomials, let's say two. Okay, so one term, two term, and three terms is trinomials. In general, we call them polynomials. So foiling, F stands for the firsts. This is the first one. This is the first one. 6m times 4m. This is O for the outers. O for the outers. Let me get different color. O for the outers. These two. Use a different color. E for the inners. These two, 1 times 4m. And I need one more color. L for the lasts. These two. So everybody knows that, but just so 6m times 4m. That's the firsts. The outers plus 6m times -3 plus the inners plus 1 times 4m plus the last plus the last ones would be 1 times -3. I think I meant to be with the last. The last would be these two. 1 times the last one from the first group is 1, the last one from the second group, or the second one if you is -3. So what do we get here? This one is 24m squared. This one is minus 18m plus 4m, and they are like terms. We add them up. -18 and 4, -14m. This is -3. So that's called foiling, which gives rise to what we call special products. It is extremely important to know them because of the reverse process. So x plus y squared is x squared plus 2xy plus y squared. X minus y squared is x squared minus 2xy plus y squared. So plus, all of them plus minus, this middle term gets a negative sign. Xy, x plus y times x minus y is x squared minus y squared. These are special products. So this is multiplication. Reverse process is factoring. So that's why you need to know the special product, because it will help with factoring. We look at one of them as an example, so you see that how we arrive at the answer. For example, if you look at this one, you can do the foiling x plus y times x plus y. So you see how that works. So we are going to multiply the x by the second piece. We get x squared plus xy. Now we multiply the y by the second parentheses. We get yx. plus y squared. And please understand xy or yx makes no difference. These two add up to 2xy, and that's what we get here. So FOIL. All right. A general review of factoring, everybody. I want to go over that for everybody. A general review of factoring is as follows. The very first step, excuse me, is to get the GCF, the greatest common factor. So any monomial, that means one term GCF. That's the first step in any factoring. Number two, consider the number of terms. So depending on how many terms we have, we move accordingly. If we have 4 terms, in fact, 4 or more, or one might say more than 3, you have no choice but to do some sort of a grouping, factor by group. If you have 3 terms, a few situations happen. Part A, you may have a perfect square. That's why in the previous page we went over these special products. So if it's in the form of a squared plus 2ab plus b squared, you have a plus b quantity squared. If it's in the form of a squared minus 2ab plus b squared, we have a minus b quantity squared. If it's not a perfect square, and the coefficient of highest degree term x squared is 1, x squared plus bx plus c, you want 2 factors, 2 numbers, okay, that are considered factors of c, the constant, whose sum is equal to b, okay, so you want 2 numbers, okay, the product is c, the sum is b, and you would put x plus the first number times x plus the second. Now, if instead of this, x squared has a coefficient a, so ax squared plus bx plus c, where a is not equal to 1, then we can use the trial and error, or find 2 factors of a times c. Even over here, we would say a times c, but since a is 1, we didn't have to, we just said c, it's 1 times c, right? So you want to find 2 factors of ac, whose sum is b. Write these factors as coefficient of 2 like terms that when combined equal bx, and then factor by grouping. Ultimately, make up 4 terms out of this by cutting the bx into 2 parts such that one part in combination with ax squared and one part in combination with c. They can be factored and create a common factor. That's the idea. What if we have 2 terms? Again, bear in mind that we have taken the GCF out. That's the very first step. So either it can or cannot be factored. If it can be factored, it's in the following form. A difference of squares. That's one of those special products we discussed in the previous page. A squared minus B squared is A plus B times A minus B. A sum of cubes. A cubed plus B cubed is A plus B times A squared minus AB plus B squared. A difference of cubes. A cubed minus B cubed is A minus B times A squared plus AB plus B squared. Couple of things I want to mention. Either one of them has one negative sign. This one has the negative sign inside the second parenthesis. A cubed minus B cubed has the negative sign inside the first parenthesis. That's the difference between the two. Also, this second parenthesis, A squared minus AB plus B squared, or this one is A squared plus AB plus B squared. Please don't mix them up with this. This is a perfect square trinomial because you have minus 2 here, and this one you have a positive 2, but we don't have it here. So A squared minus AB plus B squared is a prime polynomial. It can't be factored. So is A squared plus AB plus B squared. And of course, as always, you can check by multiplying the factors. In other words, after you're done, you can check your work, multiply to make sure you haven't made a mistake. We want to factor this, and remember the very first step is to take the common factor, which is y squared. If you want to take a couple of steps, we would say, okay, this is y squared times what? Times 9y cubed. This is y squared times 1. And so if I take the common factor of y squared out, it gives me 9y cubed. This gives me whatever this sign is, and this number. So y squared times 9y cubed plus 1. And I hope you can go from here to here without having to write this. But if you need to, you can. MP squared plus 7m plus 3p squared plus 21. We have 4 terms, which means we have to do some sort of grouping. So you start with the first two and the last two. If it works, fine. So we're going to put these two together and these two together. It may or may not work. If it works, fine. If it doesn't work, you can put this one and this one together. If it doesn't work, you can put this one and this one together. So it's a trial and error. So first start with the first two and combine them in the following manner. So the idea is that to take a factor, a common factor out such that they both have the same common factor. We notice we can take out the m from here, which results in m times p squared plus 7. This one, we can take number 3 out, which creates the same factor p squared plus 7. So one more time. If I put the first two together, the common factor is m. We take it out, we get p squared plus 7. The last two, number 3 is in common, and we get p squared plus 7, which is the same thing. So for the next step, everybody, first, write this one is which is in common. And then, so that's the first parenthesis. Then in the second parenthesis, put whatever is left. M is left, you write it. And then what is left? Plus 3, whatever the sign is. So first put p squared plus 7. And then what is left? M plus 3, including the sign. Factoring special products. Perfect square trinomial. I'm reminding you of what we mentioned. X squared plus 2xy plus y squared is x plus y quantity squared. X squared minus 2xy plus y squared is x minus y quantity squared. And we are supposed to factor the following. 16p squared minus 40p cubed plus 25q. Again, the very first step is taking a GCF out. So as we look at this, we don't see any GCF. But what do we notice? We notice that 16p squared is a perfect square number. So it's a perfect square of what? 4p quantity squared. We also notice this is a perfect square. Perfect square of what? 5q quantity squared. So most likely, this follows either this one or that one. And you have to check. And the way you check is this. If I multiply 4p by 5q by 2, 4 times 5, 20pq times 2, I get 40pq. If it's a positive value, I go with this one. If it's a negative value, I go for this one. So I have 4p squared minus 2 times 4p times 5q plus 5q squared. Therefore, it's this format, 4p minus 5q, x minus y, quantity squared. That's how you arrive at the answer. So it's pretty straightforward, everybody. We look at the next one, and the same thing happens. First, we are looking for a common factor, a GCF, it doesn't exist. Then we look at 169. It's a perfect square of number 13. So therefore, this is 13x quantity squared. Let's make a note of it. So this is 13x quantity squared. 16y to the power of 4, 4y squared. If you raise it to the power of 2, you get 16y to the power of 4. Also, notice if you multiply these two, 4 times 13 is 52 times 2 is 104x y squared. So it works. This is how you're checking, okay? So one more time. This one is a perfect square of 13x. The last one is a perfect square of 4y squared. The middle term must be the product of these two and then either times 2 or negative 2. This one was times negative 2. This one is times positive 2, and that sounds good. And that's important. Positive or negative 2 accordingly, okay? So that works out. And so the answer is parentheses 13x plus 4y squared to the power of 2. If you have any doubts, you square this and you have to get this answer. But like I said, when we check this middle term, everything is in order. All right, when we move to the next one, we look at the concept of the difference of squares. X squared minus y squared is x plus y times x minus y. Now 4m squared minus 9 it's in the same form. Why is that? You notice this one is something to the power of 2. 2m to the power of 2 minus 9 is something to the power of 2. That 9 is 3 squared. So that works out in the same manner. And so if that is the case, we have 2m plus 3, 2m minus 3 as the answer in any order. And again, it's easy to check, but more importantly, it follows the pattern. So it's all about pattern and recognition of patterns, everybody. When it comes to special factoring, you have to recognize all those patterns and everything will fall into place. We continue with factoring special products, difference and sum of cubes. It was in the summary, it was mentioned. So difference of cubes, x cubed minus y cubed is x minus y times x squared plus xy plus y squared. X cubed plus y cubed is x plus y times x squared minus xy plus y squared. And by the way, you can use x cubed minus y cubed or a cubed minus b cubed. It's just different variables that one uses, and it makes no difference whatsoever. So what's going on here? We want to factor x cubed plus 27. And the very first thing we need to do is to change this so we recognize what we are dealing with. So 27 changes to 3 cubed. So x cubed plus 3 cubed, we are going to follow this pattern, where x is x and y is 3. So replace the y in essence with 3 here. That's all. So think about this as y. Okay. So x plus y becomes x plus 3. X squared minus xy becomes minus x times 3 or minus 3x. Plus y squared becomes plus 3 squared. So you keep everything the same. You must change the 3 squared to 9. And that would be the final answer. Lowest term of a rational expression, fundamental principle of fractions. AC over BC is equal to A over B because you drop the common factor of C. Needless to say, the denominator can't be 0. So B is not 0, C is not 0 either. So we want to simplify this expression. And to do so, we have to be very comfortable with factoring. So we are going to factor the numerator and the denominator first and foremost. It's very easy to factor the denominator, everybody. So just for the sake of argument, because I want to show you how you can figure out if this can be simplified or not. If you look at the denominator, you can take the common factor of 5p out, gives you p plus 4. So one thing that will help you with the numerator is that either this expression cannot be simplified, or if it can, the top must have either a factor of 5, it doesn't, a factor of p, it doesn't, or a factor of p plus 4. So you can even just put this here and try it. This is the trial and error. You say, okay, if it can be factored, I need to have p plus 4, if it can be simplified. And so because this number is 2, and 2 is a prime number, p and 2p, okay? And this one, you just have to have factors of 4. Remember, if you go with the trial and error without paying attention to this 4, everybody, this can be 1 and 4, one of them negative, or 2 and 2, one of them negative. Now, the reason it can't be 2 and 2, because if it could be 2 and 2, that means we could have factored the 2. So it can't be. So it has to be 1 and 4. And we already know it's p plus 4 here. So you need 2p minus 1 here. So this would be the trial and error. Common factor of p plus 4 is dropped. You get 2p minus 1 over 5p. And that's the final answer. What I want to show you is, just for practice, I want to remind you, what if we didn't have the denominator and we didn't know how to factor it, and we wanted to go the numerator, 2p squared. Let me write down. The numerator is 2p squared plus 7p minus 4. What if we wanted to factor it from the scratch? Again, the trial and error, is very simple because 2 is a prime number. It makes it really easy. And 4 has only 2 factors. You can go with 2 and 2 or 1 and 4, and of course, one of them negative. So the trial and error with a few pieces, you can get to the answer. The methodology that I want to discuss is the one that we had discussed in the beginning. A is a 2, C is negative a 4. So A is 2, C is negative a 4, and A times C is 2 times negative 4, which is negative 8. Now you want to cut this into 2 pieces, okay, such that there's some, when I say 2 pieces, 2 factors, okay, that they add up to 7, okay? So, for example, 1 and 8 must be one of them negative. So if I put this one negative, then minus 1 and 8, they add up to 7. So now this 7p, and let me write the 2p squared and minus 4. And this 7p, we are going to write it as minus p plus 8p. So using those, minus p plus 8p. And now the first two, these two, we take out the p, we get 2p minus 1. The last two, we take the 4 out, and we get the same 2p minus 1. And this can be factored into what you have here. Again, the trial and error or the AC method that was discussed. Either way, it's pretty straightforward, everybody, okay? All right, multiplying and dividing rational expressions and multiplying and dividing fractions in essence. A over B times C over D, you multiply the top AC, you multiply the bottom B. If you're dividing A over B divided by C over D, you pick the first one and you keep it, and the second one you flip it over, A over B times D over C. And of course, C over D can't be 0 because you're dividing by. So just the way you would do numbers, you would do expressions. So when you perform the operations, and again, you don't have to take too many steps. I'll show you, and then I'll show you the easy way out. For the sake of argument, you can cut every number into pieces. So 2 is fine, 27 is, because the bottom is 9, 3 times 9, and 8 cut it into 2 to 4. So 2 remains, y squared remains. 27 is 9 times 3, because the bottom has 9. 8, you cut it into 2 and 4. And y to the power of 5, you can write y squared times y cubed. And so things start canceling each other. The 2's cancel out, the 9's cancel out. So the y squareds are identical, they cancel out. And you're left with 3 over 4 y cubed. Or you can do that right here. I'm going to go back to the original one. And the second method instead of writing it out in this fashion, if you're comfortable simplifying just the way you see it, that works. So right here, you drop the 2y squared with 8y cubed, and you get 4y cubed. You drop the 9, you change the 27 to 3, and right here, you have the answer. So I think, to me, that's easier, but it's your choice, okay? Just want to make sure that no one has any problem with that. 3p squared plus 11p minus 4 over 24p cubed minus 8p squared divided by 9p plus 36 over 24p to the power of 4 minus 36p cubed. What we are going to do, first we're going to look at this one and factor it. So it's a very simple process. What can we notice? As you can see, number 3 is a prime number. So never mind the second piece. I'll discuss that in a minute. It's a prime number, so you have to go with p and 3p. I hope you see that. 4, you have to go with 1 and 4, or 2 and 2, both of them. One of them negative because it's negative 4. And you have to work it out such that the middle term works. So this is a trial and error, and I've shown you the AC method also, okay? So you just play with that. Because the number here is pretty large, this 11, you try 4 and 1. So if you put a 4 here, it works. Notice, because the product of these two is 12p, this is p, they add up to positive 11p. The bottom is simple. The bottom, all you have to do, everybody, take the 8p squared out, gives you 3p minus 1. Division, you flip this over. So first and foremost, you change this to the following. You change this to times 24 p to the power of 4 minus 36 p cubed over 9 p plus 36. First, you flip this over. That's the first step. Now let's see what happens. This one, 12, between 24 and 36, 12 is in common. So 12 p cubed, because between p cubed and p to the power 4, p cubed is in common. So 12p cubed times 2p minus 3. Over here, 9 is in common, p plus 4. So one more time, this becomes p plus 4 times 3p minus 1. This becomes 8p squared times 3p minus 1. This flips over, and 24p to the power 4 minus 36p cubed. We take the 12p cubed out from the bottom and put it at top, times 2p minus 3. The top, we take out the 9 and we put it at the bottom. And we are going to simplify. 3p minus 1 drops. P plus 4 drops. And because we don't want it to get crammed, we can continue with that, but let's just write what we have. What is left is 12p cubed times 2p minus 3 in the numerator, 8p squared times 9 in the denominator, and we can factor things out as follows. Eight p squared and 12p cubed, we can divide them by 4p squared. We get 2, and we get 3p here. Number 3, we can drop it and change this to 3. And the final answer would be p times 2p minus 3 over 6. And that is the final answer.